In this video, I want to have a look at odd and even functions. So to help us graph functions, one of the things that we should consider is whether the graph is symmetrical. The first type of symmetry we look at is called even symmetry, and that's where the graph is symmetrical through a reflection over the y-axis. So like this parabola that we've got here, if we draw a line straight down the middle there, we can see that it's symmetrical across that line, so it's just been flipped straight over. Same with this curve over here, it's symmetrical across that line. The second type of symmetry that we're going to have a look at is odd symmetry, and that's when it's rotational symmetry about that origin, so about the middle point. We could spin it and it would sit on top of itself. Again, this one, if we spun this whole line around 180 degrees, it would sit perfectly on top of itself again. It's important to know that even though we look at these odd and even symmetries, there are lots of functions that won't be either odd or even symmetry. They just won't have any symmetry at all, or they might be symmetrical about another point or through another reflection. So we want to be able to test for symmetry without having to sketch each graph and check. So we can do it algebraically using these two rules. So if our function is even, then f of x is going to be equal to f of minus x. So when we make that substitution in, we should end up getting back to exactly the same function. And the reason that works is, say we had a value x here, f of x means the value of the function at that point, so reading off that y value. If we then read the graph at f of minus x, so the same number but in the negative direction, then the function has a value here which is exactly the same. So the value of the function at x is exactly the same as the value of the function at minus x. For an odd function, we're going to have f of x is equal to minus f of minus x. And that's because if we had, say, x here, then the value of our function would be here, and it would be whatever that is there. If we then go to minus x, then the value of our function here, it'll have the same magnitude, but it will be negative instead. So say this was a 4, this would be minus 4. If it was a 20, that would be a minus 20. So the value of the function at x is going to be negative the value of the function at minus x. I want to have a look now at a few examples of testing algebraically whether a function is odd, even, or neither. So our first example, we've got f of x is equal to 4x squared minus 2. So we want to find f of minus x. So that's going to give us 4 and then minus x squared and then minus 2. But we know that's like a minus 1x, and if we square minus 1, it's just going to become 1. So a minus x squared is just the same thing as an x squared. So that's the same thing as having 4x squared minus 2, which is exactly the function that we started with at the start. Okay? So that means that that function is even. In our second example, we've got the function f of x is equal to x cubed plus 5x. So if we substitute in minus x there to find f of minus x, we're going to have minus x all cubed plus 5 times minus x. So when you cube a negative 1, that's still going to give you a minus 1. So that's like a minus x cubed. It's the same with or without the brackets in that one. And then this positive 5 times a minus 1x would give us minus 5x. So this is looking pretty similar to our original function, except that they've got these negatives here. So if we pull that negative out the front, we'd have x cubed plus 5x. So that means that we've got minus f of x. So because we've then got f of minus x is equal to minus f of x, that's the same thing as writing f of x is equal to minus f of minus x, if we just pulled that negative over the other side. So that means that this function is odd. If you're testing a function and it doesn't come out with either of those patterns, you can't pull a negative out or anything like that, it means that it's neither. So that's a few examples of odd and even functions.